Building a PC has never been easier. Every part only fits one way. Every socket's labeled, and there's a tutorial for literally every screw. So why do people still fry brand new hardware before they even install Windows? Usually it's not anything exotic. It's small, dumb, avoidable stuff. A piece of plastic left on, a wire in the wrong hole, a part installed at a slight angle. So let's flip the usual video around. Instead of how to build a PC, here's how not to. Careless CPU installation. The easiest part to destroy in your whole build isn't the GPU, it's the CPU socket. On modern Intel and recent AMD boards, the pins aren't on the CPU, they're in the motherboard socket, hundreds, sometimes over 1,000, tiny gold contacts. They look tough, but they're not slide the CPU in at an angle or force it, and you can bend several instantly. Since those pins belong to the board, not the chip, you've just damaged your motherboard, not your CPU. The fix is almost too simple. Line up the little triangle on the CPU with the one on the socket, hold it above the slot, and let it drop straight down. Gravity does the work. If you feel yourself pushing or wiggling it into place, stop. That's the signal something's wrong. 10 seconds of patience. Here's the difference between a clean build and a dead motherboard. The forgotten I/O shield. This one's basically a rite of passage. I've done it myself. You finish the whole build. CPU's in, coolers mounted, cables are routed clean. Then you spot a small rectangle of metal sitting on the table, the I/O shield. It was supposed to click into the case before the motherboard went in, and now fixing it means undoing half your work. It doesn't affect performance. Your PC will run fine without it, but it supports the rear ports, helps block electrical interference, and seals up the back of the case so dust doesn't just wander in. Some newer boards build it in already, but plenty still use the old removable plate. So before you screw the motherboard down, check that it's clipped into the case first. Motherboard standoffs. Your motherboard should never touch the metal case directly. That's what standoffs are for. These small brass spacers lift the board just enough to keep its underside, covered in exposed solder points, off the bare metal. Most cases come with the right standoffs pre-installed. But switch board sizes, or use a smaller case, and you'll want to double check. There are two ways to get this wrong. Too few standoffs, and the board can sag and short against the case. Too many, and a spacer sitting where there's no mounting hole presses straight into circuit traces, creating the exact short you were trying to avoid. The fix, before dropping the motherboard in, match every mounting hole to a standoff underneath it. One hole, one standoff, no more, no less. Front panel connectors. You can install every expensive component flawlessly and still get beaten by 4 tiny wires. Power switch, reset switch, power LED, drive activity light, they plug into a small header usually tucked in a bottom corner, and unlike most connectors in your PC, they're not consistently keyed or color-coded. It's easy to get one pin off or swap the power and reset switches without noticing, which leads to the classic moment. Everything's installed correctly and you press the power button and nothing happens. Most people assume the worst: dead PSU, defective board, bad CPU. Usually it's just one wire on the wrong pin. The fix: pull up the front panel header diagram in your manual and check each wire against it. 5 minutes here beats an hour of panicked troubleshooting. RAM in the wrong slots. This mistake looks more correct than the right way of doing it. Most people put 2 RAM sticks in the 2 slots right next to each other. It just looks tidier, but most CPUs run 2 memory channels, and to use both, the sticks need to go into specific non-adjacent slots, usually the second and fourth from the CPU. Get it wrong, and your system quietly drops to single channel mode, cutting your memory bandwidth roughly in half. That shows up as lower frame rates in games and slower renders in creative work, with nothing on screen telling you why. Some boards will still run dual channel and other combos, but manufacturers test and validate specific slots for the cleanest signal. Check your manual before installing. Leaving free performance on the table. Imagine a sports car that can hit 200 miles per hour but ships limited to 120 until you flip one switch. That's what happens inside a lot of gaming PCs. You buy a fast DDR5 kit rated for 6,000, 6,400, 7,200 megatransfers per second, install it correctly and boot up. Everything looks fine. But by default, motherboards run RAM at a conservative baseline, often around 4,800 megatransfers per second for DDR5, because that's guaranteed to work with almost any chip. Your expensive kit could be running 20 to 30% slower than its rating, with no warning. The fix is one BIOS toggle. XMP on Intel, Expo on AMD, it applies the tested speed, timings, and voltage the kit was built for. You'll feel it most in CPU-heavy games, but also in editing, compiling, and other memory-hungry tasks. Some extreme kits need manual tuning, but if you never touch this setting at all, you've paid for speed your PC never uses. Thermal paste myths. Ask 10 builders how to apply thermal paste, and you'll get 10 different answers. P, X, line, spread it with a card. Good news, most of them work fine. Paste just fills the microscopic gaps between the CPU and cooler, since even smooth-looking surfaces have tiny ridges that trap air, and air is a terrible conductor of heat. The real mistake isn't the pattern, it's using way too much or too little. Too little leaves bare spots, too much just gets messy. What actually matters more is mounting pressure. Tighten one corner down fully before the others, and the cooler can sit tilted, giving good contact on one side and gaps on the other. Higher temps, harder working fans. Instead, tighten the screws gradually in a crisscross pattern until everything's evenly seated. Even pressure beats the perfect paste shape. The plastic film everyone forgets. Every generation of builders goes through this one. You finish the build, hit power, everything spins up, and the CPU temperature rockets toward 95 degrees Celsius while the fans scream. The cause? A thin protective film still stuck to the cooler's cold plate. They're only to prevent scratches during shipping. Leave it on, and you've installed a plastic insulator between your CPU and its cooler. Heat can't transfer properly, so the CPU throttles hard or shuts down to protect itself, which is good for the chip, but means the processor you paid for is performing like a much cheaper one. The fix: before mounting any cooler, flip it over and check the cold plate for a sticker or film. If it says remove before installation, remove it. Fighting your own airflow. Cooling isn't just about adding fans, it's about making them work together. A common mistake is setting every fan to intake or every fan to exhaust. Neither works well. You want a clear path. Cool air in through the front, hot air out through the back and top, sweeping across the GPU, cooler motherboard, and drives on the way through. Cable management matters too. Loose cables bunched in front of an intake fan can block airflow before it even enters the case, like parking furniture in front of an AC vent. And the stakes are real. Modern GPUs dump hundreds of watts of heat into the case, and if that's not replaced with fresh air, everything runs hotter: GPU, CPU, motherboard, even your SSD, and fans spin up louder to compensate. A few minutes planning airflow beats buying another fan later. Wrong M2 slot for your SSD. Not all M2 slots on your motherboard are the same, even though they look identical. Usually only the primary slot connects straight to the CPU. The others typically route through the chipset, sharing bandwidth with USB, networking, and SATA. For everyday use, you won't notice. But for heavy file transfers or pro workloads, that shared connection can bottleneck. If you've got a fast Gen 4 or Gen 5 SSD, put it in the CPU connected slot when you can. SSD heat spreaders? Quick one. Don't peel the label off a new SSD. It looks like packaging, but on a lot of drives, that label is doubling as a heat spreader, helping pull heat off the controller. Remove it, and you can lose a bit of cooling performance, and on some drives even affect the warranty. Easiest fix on this whole list: just leave it alone. SSD placement behind the GPU. Where your SSD physically sits matters too. A drive mounted right under a big graphics card sits directly in its exhaust path, constantly hit with hot air during long sessions or big transfers. Enough heat, and the SSD controller throttles itself to stay safe, slowing down transfer speeds right when you need them most. Use your board's M2 heatsink if it has one, and keep some airflow around the drive instead of letting it sit under the GPU. Wrong PCIe slot for your GPU. Most boards have multiple full-length PCIe slots that look identical but aren't. The top slot is almost always wired directly to the CPU and meant for your main GPU. Lower slots often get fewer lanes or route through the chipset. Put your card in the wrong one, and you can lose bandwidth between it and the CPU. Sometimes barely noticeable, sometimes showing up as stutter or lower minimum frame rates on powerful cards or bandwidth-heavy work like AI or rendering. Unless your manual says otherwise, always use the top full-length slot. Monitor plugged into the wrong port. Everything's built, Windows installs fine, and your new gaming PC performs like an office computer. The cause: the monitor's plugged into the motherboard instead of the graphics card that routes you through the CPU's integrated graphics. Fine for browsing. Nowhere close to a dedicated GPU. Your graphics card has its own set of ports, usually lower on the back of the case. Whether it's HDMI or DisplayPort, that's where the cable goes. Ignoring GPU Sag. Graphics cards have gotten huge. Some flagship models stretch past 35 centimeters and weigh more than some small form factor PCs, held up by little more than a couple of screws and the PCIe slot itself. Over time, gravity pulls on that unsupported end, causing GPU sag. Mostly it's cosmetic, but sustained sag, especially if the PC gets moved a lot, adds mechanical stress to the connector, the slot, and the card's own PCB. Nothing's going to snap overnight, but it's cheap to avoid. GPU support brackets are inexpensive, and some cards even include one in the box. Daisy chaining PCIe power cables. Flagship GPUs can pull over 400 watts, and modular PSUs often ship with daisy chain cables, one cable, two connectors. That was fine when GPUs drew a lot less power. For today's hungriest cards, running both connectors off one cable can mean more heat, more connector stress, and more voltage drop under load. When your card needs multiple PCIe connectors, use separate cables where possible. Each one carries less current and gives more headroom for spikes. Mid-range cards are usually fine with a single daisy chain cable, if the PSU maker allows it, but for enthusiast tier hardware, hardware. Separate cables are the safer call. Cheap power supplies. Ask someone what the most important part of a gaming PC is, and almost nobody says the power supply. Yet it's wired directly into everything else. Modern CPUs and GPUs don't draw power steadily, they spike, sometimes hard, and a cheap PSU can struggle to keep up. Better units use higher quality parts and include protections like overcurrent, overvoltage, and short circuit protection, so if something goes wrong, the PSU takes the hit instead of the rest of your system. You don't need the most expensive one on the shelf, just a reputable brand, enough capacity, and solid independent reviews behind it. Balanced components. One last mistake and it happens before you ever pick up a screwdriver. Buying parts that don't make sense together. A PC is a system, so if one part can't keep up, the rest end up waiting. Pair a flagship GPU with a budget CPU and the GPU spends time waiting for frames. Do the opposite, and now the CPU is waiting on the GPU instead. The goal is to keep your parts roughly balanced for your budget. The same idea applies to the rest of your build. Take storage for example. Gen 5 SSDs sound impressive, but most games simply don't move enough data to make a noticeable difference over a Gen 4 drive. In many cases, loading times are only a few seconds apart. The same goes for memory. More isn't automatically better. For most gaming PCs, 32 gigabytes of RAM is already plenty. Going up to 64 gigabytes or more mainly benefits heavier workloads like video editing or three-dimensional rendering. Motherboards are another common example. Premium models come with extra ports and features, but if you're never going to use them, that money is often better spent on a faster CPU or GPU. Your monitor matters too. A GPU capable of pushing 200 frames per second doesn't mean much if you're gaming on a 60Hz display. On the other hand, pairing a high refresh rate 4K monitor with a weaker GPU will leave you struggling to hit smooth frame rates. And finally, don't skimp on your power supply. Leave yourself some wattage headroom. Modern GPUs can briefly spike well above their average power draw, and having that extra margin helps keep your system stable over the long run. 18 ways to accidentally sabotage a build, and most of them come down to something tiny. A wire one pin off, a piece of plastic left on, a cable in the wrong port. Building a PC was never about avoiding every mistake. Even experienced builders forget an I/O shield now and then. The difference experience gives you is just knowing where to look first. If this saved you from one of these, that's what the like button's for. And if you've already made one of these mistakes yourself, welcome to the club.